All right, so this will be the tutorial video for section 11.6 on spheres and hemispheres. So just scroll down here. So far, we've looked at different types of solids, prisms, pyramids, cones, cylinders, and we found the volume, how much space fills up the inside of that 3D shape, and we found the surface area. What's the area of all of the outside surfaces surrounding that 3D figure? And so we have kind of one left to go over, which is the sphere. And I always think of like a basketball or a volleyball. The Earth is an example of something that's spherical. A sphere is kind of the equivalent of like a 3D circle, I guess is what I would call it. So think of it like a ball, right? So to find the surface area of a sphere, I had you guys check out the little basketball, or not basketball, the little orange peel video linked in the agenda. And if you haven't watched that yet, pause me here and go check that out. But basically, anybody can try this. If you peel a clementine and you draw four different circles that have the radius of that clementine or orange, whatever you're using, it'll take four circles to completely use up all of the orange peel. So if you were to peel the orange little piece by little piece, it would take four circles that have the radius of the orange in order to use up all of that orange peel. So this circle has area pi r squared, this circle has area pi r squared, this circle has area pi r squared, and this circle also has area pi r squared. If you add them up, we get 4. So the surface area of a sphere, if I wanted to know how much material, maybe how much felt I need to go around a tennis ball, the total surface area of a sphere is going to be 4 pi times the radius squared. And the radius of a sphere is the distance between the center of the sphere to any point on the exterior of the sphere. So any point on the ball itself, not on the inside. Kind of like the radius of a circle. Okay, so that would be a radius. You could draw a couple more. That would be a radius. That would be a radius. Okay, and they all have the same length. If you go all the way across, then you get a diameter. So a diameter would go through the center of the sphere, cut through it, through the middle, go from one side to another. Okay, so surface area of a sphere is 4 pi r squared. The sphere has no lateral area because it has no base, no bases. Okay. The volume of a sphere to calculate, this one's a little harder to show why it works. I do have some YouTube videos if you're interested in seeing kind of the proof behind why it works. Send me an email and I'm happy to send that to you. So the volume of a sphere is 4/3 times our friend pi. And this is the only one we use the whole chapter where the radius gets raised to a power of 3. So I want you to make a note of that on your notes here. It's 4/3 pi r cubed instead of pi r squared. So I'm going to highlight that. Okay, 4/3 pi r cubed is how we compute the volume of a sphere, how much space fills up the inside of that sphere. So let's try a couple here. Let's find the surface area and the volume. It doesn't tell us whether to leave them in terms of pi or not, so let's, I guess for these first couple, we'll just leave these in terms of pi. So for the first one, I see the sphere has a radius of 8, and that's all I need to compute the surface area and volume. I don't need to know the height, I don't need to know lateral edge or anything like that. Just the radius is enough information. So the surface area of the sphere, if I use my formula, is 4 pi r squared. And this is on your formula sheet that I gave you at the beginning of the unit. So this would be 4 pi times 8 squared. And I'm just going to go to my calculator and type in 4 times 8 squared, and then just stick a pi next to it, like we've been doing the whole chapter. Oops. 4 times 8, hit the x squared button, we get 256 pi. And it's surface area, so we're still using square units. So this would be 256 pi square feet. On Math Excel, on a quiz or a test, if it asks you to round your answer to the nearest tenths place or some other decimal, then you'd actually have to multiply out the pi button on your calculator and give an appropriate decimal based on how many places it asks you to round to. Okay. The volume of the sphere, how much space is on the inside, is 4/3 pi radius cubed. So 4/3 pi, my radius is 8. I'm going to remember to cube it, and that's on your formula sheet if you need it. So I'm going to type in everything except the pi, and then I'll stick a pi on my answer. So I'm going to do 4/3 in parentheses, 4 divided by 3. close parentheses, times the radius, which is 8, cubed. And so there we go. We want an exact answer in terms of pi. That's a decimal that goes on forever. It's 0.66666, and it just keeps going on forever and ever. So I'm going to math frac my answer since that's not a nice exact decimal. And this is what we're going to put next to our pi. 2048 thirds. So 2048 pi over 3. Okay. 2048. Usually we put the pi on top. You can put it next to the whole fraction if you want. So you could also write it like this. Either way. And this would be cubic feet since we're doing volume. And again, if it asked for a decimal, then you would multiply out the pi button on your calculator. You would just do times pi, and you would give an appropriate decimal answer, maybe 2,144.7 if it asked for the nearest tenths place. All right, so there's an example of a sphere. In the second example, we only have half the sphere. This is what's called a hemisphere. And if you have taken some type of geography class, you'll know that the Earth is divided into the northern hemisphere and the southern hemisphere. And that diameter, that dividing line, is the equator. Okay? So if I look at this one, this is a hemisphere, which is half a sphere. We don't call it a semisphere. The radius they're giving me is 14, goes from the center of the hemisphere to the edge. And so to compute the surface area, what's interesting about the hemisphere is even though the full sphere didn't have any lateral area, it didn't have any base for us to have to calculate the area of. If you take, for example, like a snow globe, there is a base on the bottom. There's a circular base. So a hemisphere does have lateral area. The lateral area would be the glass part of the snow globe that comes up into the air. Okay? And then the circle on the bottom, usually sometimes it's like a fuzzy part that you can put down and it doesn't scratch the wood or doesn't scratch the table. This would be the base of the hemisphere. And so we are going to get some lateral area and base area for the hemisphere that we have to combine together. Remember, for the sphere, there's no lateral area. There's just total surface area. For the hemisphere, I'm going to do the lateral area first. You can, a couple ways you could do it. The lateral area of the sphere, which is the kind of the rounded part, it's exactly half the area of the total sphere, right? Because if I was to put kind of the northern hemisphere and the southern hemisphere together here, this contributes half the area, and then the bottom half contributes the other half of the surface area. So instead of 4 pi r squared, we can use 2 pi r squared. I'm just going to cut that coefficient in half when I'm using a hemisphere. The other way you could do it is you could find the surface area of the whole sphere, like we did in example 1, and then just divide your answer by 2 at the end. Because you won't get this on your formula sheet. This is going to be one you want to either memorize or think of it as just surface area of the sphere divided by 2. So 2 pi times 14 squared. I'm just going to type in 2 times 14 squared. And I get 392 pi. Okay. Using the other approach I mentioned, if you did 4 pi r squared, you'd have 4 times 14 squared. So this would be the surface area of the whole sphere. And then you got to divide your answer by 2. Cut it in half, you get 392. Okay. Stick a pi next to it. That's the lateral area. And then we've got the circle on the bottom, which has a radius of 14. So the base area is pi r squared. It's a circle. Pi times 14 squared would be 196 pi. And then to get the total surface area, I just add them up. It's the lateral area, the rounded part, plus the circular base on the bottom. So 392 pi plus 196 pi equals, let's add those coefficients, 396 plus, I think it was 196. 196 gives me 592 pi. And this would be feet squared for area. Okay, to get volume, same type of approach. I could find the volume of the whole sphere, and then I could just divide my answer by 2 to get the upper hemisphere. Or I could cut the coefficient in half. If I only want half the volume, instead of using 4/3, I'm going to use 2/3. So 2/3 pi r cubed would be my adjustment if I'm doing a hemisphere. instead of 4/3. Okay? So this would be 2/3 pi times 14 cubed. Let's type it in. 2 divided by 3 times 14, and then hit the exponent button to the power of 3. And math frac that, because that's not an exact answer. So math, enter, enter, 5,488 pi over 3. And this would be cubic feet. If you were to do the entire sphere first and do 4/3, I'll show you that. You do 4/3 and then times 14 cubed, math frac. Okay, there's your fraction times pi, but then divide it by 2 since we're only doing a hemisphere. There you go. There's your 5,488 thirds that we put in front of the pi. Okay, so there's our volume, how much space or maybe how much snow you could fit inside of the snow globe. And there's our surface area, maybe how much glass and felt is needed to construct the outside of it. All right, let's do a Pokeball example if there's any Pokemon fans out there. Gotta catch them all, right? If the volume of this Pokeball, the amount of space inside of it, is 972 pi cubic miles, this is a huge, massive Pokeball. Okay, so they're giving me volume. Find the diameter, d, of the Pokeball. In other words, that distance across the middle. If it was cutting through the Pokeball, through the center of that sphere, edge to edge, or not edge, but like, take a point on the sphere, cut through the middle, go all the way across. What's that distance across the center? So I want to start with the volume because that's what they gave me, and the goal is to calculate the diameter. So I'm going to start by writing my volume formula. Volume of a sphere, a Pokeball is a sphere, is 4/3 pi times radius cubed. Make sure we cube that. And so we get, let's see, what do we know? In this problem, we have to work backwards. We actually are told that the volume is 972 pi. And we're going to set that equal to 4/3 pi r cubed. Notice the only thing unknown in this equation is the radius. If I can solve for the radius, then I can just double it to get the diameter. So that's what I'm going to do. One thing I notice I can cancel on both sides is pi, if I divide both sides by pi. If I multiply both sides by the reciprocal, I can get rid of the fraction. So I'm going to multiply both sides by 3/4. And so let's figure out what we have left. On this side, the fractions go away. So I've got r cubed equals 972 times 3/4 times, and then in parentheses, 3 divided by 4 gives us 729. So now think about it this way. Let's say you had something like r squared equals 25 or something like that. In the past, we've taken a square root of both sides to solve that, and we would have gotten 5 and maybe -5 depending on the problem. Here, we can't take a square root because we have a power of 3. So what we do is we take what's called a cube root, which is something you're going to learn a lot more about in Algebra 2 next year. It looks just like a radical, except we put a tiny little 3 next to the radical symbol. And all this is asking for is what number would I need to multiply 3 times in a row instead of 2 times in a row to get me to 729. So in other words, would 5 times 5 times 5 get me to 729? Would 6 times 6 times 6? You can kind of play with it and see. The one that gets us to 729 is going to be the cube root. Okay, a little too small. Let's do 7 times 7 times 7. Nope. How about 8 times 8 times 8? Nope. Okay, 9 times 9 times 9. Ding, ding, ding. There we go. So the cube root, the radius would be 9. There is a button for this. You don't have to guess and check this every time, especially if decimals are involved. The way that you get the cube root button on the calculator is you go to the math menu on the left-hand side. It's underneath the green alpha button, and it's the 4th option down. You can either hit the number 4 or you can scroll down with your arrow to number 4. You'll see a little 3 next to a radical. Hit enter, and it should show up with a nice cube root symbol on your screen. Type in 729. We're taking the cube root of 729, which gives us 9. In other words, 9 times 9 times 9 gives me 729. Okay, so radius would be 9. Okay, and this was just a side. They asked us for the diameter. The diameter is twice the radius, so 2 times 9 would give me a diameter of 18, and we were measuring in miles. Not squared, not cubed, it's just a distance, so it would be normal miles. Okay, and kind of sit back and think about that. You have a Pokeball that's 18 miles wide. Oh my goodness, that's huge. I'm going to do a spherical wow. You can look at how to draw a sphere. Kind of make a little bit of an ovalish. There's the center. Wow. Pretty cool. Okay. Next one. If the surface area of a sphere is 2,000 inches squared, okay, so notice it's not 2,000 pi, it's just 2,000. Okay, so it's going to be a little bit more work than the other one. If the surface area is 2,000 square inches, find the volume of the sphere. So this is one of those problems where we have to work with both formulas in order to help each other out. We're given surface area, we need volume. So I would start by just writing the formulas out. Surface area is 4 pi r squared. It's not a hemisphere, it's a full sphere. Volume is 4/3 pi r cubed. So kind of look at the formulas and see what do we have and what do we need. We know the surface area is 2,000, so we can substitute that in for surface area. And the only unknown variable then would be the radius. So step 1 is going to be find the radius. And why would that help me? Because if I come over here to get the volume, I need to know the radius before I can use the volume formula for a sphere. So I'm going to use the surface area. Surface area is 4 pi r squared. They told me the surface area in this problem is 2,000. And so what I'm going to do on the calculator, notice there's no pi for me to cancel this time on the other side. But 4 pi is just a number, right? 4 pi is 4 times 3.14159, etc. So this whole thing right here, this is just a number. And how do I get rid of numbers that are multiplied by a variable? I divide. So I'm going to start by just dividing both sides by 4 pi. And I always put it in parentheses, because if you don't put it in parentheses on the calculator, it's not going to give you the correct answer. I'll show you what happens. If you type in 2,000, this is not the way to type it in, divided by 4 pi without parentheses. What your calculator is going to do is it's going to divide 2,000 by 4. It's going to calculate that first, and then it's going to multiply your answer by pi. But you want the 4 pi to be in the entire denominator. So this would not be correct. What you want to do is 2,000 divided by, put parentheses around the 4 pi. I want the 4 to be in the denominator, and I want the pi to be in the denominator. There's my radius, 159.154 ... Okay, leave that on your screen because we're not done with the problem yet. Just like we've been using in previous chapters, we're going to continue the calculation. So I'll round it on paper for now. Okay, so r squared is 159.155. But I'm not using that on my calculator. I'm going to use the full decimal when I keep going. Now I need to square root to undo the square. Notice I'm not using a cube root for this one. I'm using a square root because it was to the power of 2. The only time we use the cube root is when it's a power of 3. So I'm going to take the square root of my answer. Second, x squared, hit the up arrow, or you can retype the decimal if you want. There we go. Okay, there's my radius. Again, leave it on the screen. We're not done yet. 12.616. So come over here. Radius is 12.616 inches. Now we have to find the volume. So step 2 is we're going to get the volume now that we know the radius. So the volume is 4/3 pi r cubed. We're going to plug in that long decimal and we'll round to the nearest hundredth. Since it's asking me to round, that means that I want to use the pi button on my calculator. My radius was, I'm going to write the abbreviated version here, but you want to use the entire decimal on your calculator. Make sure you're doing r cubed. So we're going to have 4/3 in parentheses times pi, second exponent button, times in parentheses, open parentheses, hit the up arrow, grab the decimal, hit enter, or retype it, close parenthesis, hit the exponent button to the power of 3. So take a pause the video if you need to check, make sure you're typing this in on your own calculator and getting the right answer here. And moment of truth, our volume is 8,410.44 if we round to the nearest hundredths place. Okay. 8, 4, let me get those digits again, 8410.44. And this would be volume, so it would be inches cubed, since we're doing space inside of the sphere. Okay. And you're going to get problems. I think on Math Excel, I have a couple where it goes backwards. They might give you the volume, so you might actually start with this formula, and you'll have to multiply both sides by 3/4, divide by pi, cube root, get the radius, and then go over here to the surface area formula and plug it in to get the surface area instead. So there's kind of two approaches you want to make sure you're practicing. Given surface area, you should be able to get the volume. Given volume, you should be able to go backwards and get the surface area. Okay, so you'll have some on Math Excel that you definitely want to practice. This is one of the tougher types of questions from this section. Okay, application problem. I see ice cream. Yum. Okay, if an ice cream scoop, which notice is a sphere, there's one sphere, there's a second sphere. An ice cream scoop creates 3-inch diameter scoops. So the distance across the center from one point on the sphere to another, that diameter is 3 inches. So in other words, the radius would be 1.5 inches, half as big. Okay. Diameter is 3 inches. How much ice cream is on that cone? Well, we have to first decide, are they asking about surface area or volume? The ice cream, that scoop of ice cream, takes up space. Once it melts, it's all liquid, right? So I'm not just concerned about the surface of the ice cream. I want to know how much ice cream is actually on that cone. Means what's the volume, the total volume of both of those spherical cubes of ice cream. So first thing I'm going to note is that this is a volume problem, because I care about the space inside of the ice cream. It didn't ask me how much waffle material I have for the cone or anything like that. It's asking about the volume of the ice cream. Well, we have two spheres. So we could find the volume of this first sphere and the volume of the second sphere and add them together. But notice it's the same sphere twice. This one also has a radius of 1.5. So all I'm going to do is I'm going to find the volume of a scoop, and I'm going to double my answer. So this would be one scoop of ice cream. 4/3 pi radius cubed. Instead of putting in 3 for the diameter, I'm going to put in 1.5 for the radius. Let's see what that gives us. 4/3 in parentheses, and we'll do decimals for this problem since it's a word problem, times pi, second exponent button, times 1.5 exponent button. Make sure you're cubing it, not squaring it. This would be one scoop of ice cream. Okay, leave the decimal on your screen. 14.137. And that would take up maybe my, let's see, flavors. There's my raspberry scoop. Okay. Pick your favorite flavor. I actually don't like raspberry. And let's throw some, what's green? I don't know, some type of sherbet maybe. Now I'm going to double my answer to know how much space the second one takes up. So this will now be the combined total of both scoops. Times 2, they have the same volume since the radius was the same. It's the exact same sphere, just listed twice. This is going to give me times 2, 28 point, I'll round to the nearest tenths place, 28.3. Oh, they said 2 decimal places for our answer, so let's do that. 28.27. Units, cubic inches of ice cream. And again, you can kind of play around with the formulas. The other way you could do this is kind of similar to what we did with the hemisphere. If one scoop is 4/3 pi r cubed, you could kind of adapt the formula. We're just multiplying it by 2. So if I multiply 4/3 by 2, if I wanted to get the calculation done in one step, I could do 8/3 pi r cubed. Let's try that and see if it gives us the same answer. 8/3 pi times 1.5 cubed. Moment of truth. 8 divided by 3. Kind of like when I cut it in half before, except now I'm doubling it since I have 2 scoops, not half a scoop. Pi times 1.5 to the power of 3. Oops. 3. And we get the same answer. So again, take your pick. The only ones you're going to get on the formula sheet are the ones from the box on the first page. Any others that you want to be able to use quickly, you got to memorize or do the little tricks of just multiplying by 2, dividing by 2, and just using these as your toolbox. Okay. Last one here. Some composite practice. That's definitely something I know some of us want some more practice with, so let's go through this. Find the total surface area and the total volume of the composite solid below. Okay. Round each of your final answers to 2 decimal places. So what it looks like, let's kind of look at what we've got. It looks like I've got a cone sitting on top of a bowl. And what would that bowl be? Well, it's not a cylinder because it doesn't have another circle on the bottom. It's actually curvy here. This is a hemisphere. Okay. The one that I'm outlining kind of in green and in red. This would be a hemisphere. Think of a cereal bowl. And we're putting a cone on top of it. Looking at the dimensions, it looks like the radius of the cone, which would be the same as the radius of the hemisphere, this distance that I'm highlighting here in yellow, that radius would be 39. So radius is 39. The distance from top to bottom, all the way from the vertex of the cone down to the bottom of the bowl. I'm going to draw a different colored line. Let's do pink. All the way down through the center, doesn't stop there, keeps going. That whole distance is 81. So what's interesting is that's kind of taking into account the height of the cone. If I was to go from top to bottom for the cone, this part right here that I'm kind of making green, that would be the height of my cone. Oop, I think it got overlapped. There we go. So then what's this leftover pink distance? Well, that's just another radius of the hemisphere. It still goes from the center to an edge. Maybe let me draw it off to the side so you can see it. There's my hemisphere. This is a radius. This is another radius. I know I didn't draw it to scale, but it still goes from the center and hits a point on the bowl. This would be another radius. They all have the same length. So that would be 39 also. So then if I do 81, take off, this was 39, what's going to be left here? 81 minus 39 would be 42. So the height of that cone, the part that I have in green here, height of the cone is going to be 42 feet. Okay. Okay, so let's do total surface area, total volume. Let's do surface area first, usually a little bit trickier. Looks like we are not including the base because I cannot touch the circle at the top of the hemisphere and I can't touch the bottom of the cone. So I'm only looking at lateral area in this problem. I'm going to cover the party hat part of the cone, not the hole on the bottom where my head's going to go. So I need the lateral area of the cone, plus I need the ceramic part of the cereal bowl. I don't need the hole at the top where I'm going to pour the cereal, but I can touch the outside. So I can touch this part of the cone, touch, check, and I can touch the lateral area of that hemisphere. But since the cone's on top, I can't touch that open hole. So I'm only going to do lateral area of cone plus the lateral area of the hemisphere. And so plugging in our formulas, lateral area of a cone is pi times radius times slant height, plus lateral area of a hemisphere. Remember from the last example we did on the first page, the total surface area of a sphere is 4 pi r squared. That takes up the entire top and the entire bottom. So if I only want half of that, I'm going to use 2 pi r squared, or I'm going to just make sure that I take 4 pi r squared and divide my answer by 2 when I'm done. I kind of like to go the shorter route and just do 2 pi r squared. Okay. But I'm not adding that circle on for the base because it's covered. Okay, well, we got a radius, check, that's 39. We do not have a slant height, so I would say let's draw our cone off to the side and let's calculate that slant height. The height we calculated was 42. The radius is 39. And so a little Pythagorean theorem, I'm going to focus on this little triangle right here. If I calculate that, 42 squared plus 39 squared equals slant height squared. Let's do 42 squared plus 39 squared plus 39 squared. And we get 3285. That is the slant height squared, so we need to take the square root. And I would just leave it like that for now. We're not done with the problem yet. If you want to get the decimal, you can, but just leave it on your screen because we're going to keep using it when we go back here. Okay, so now I know the slant height and I know the radius, so I can plug in pi times radius of the cone was the same as the radius of the hemisphere, 39. Slant height, we just calculated square root of 3285. So there's the party hat component. Plus, now we've got the hemisphere on the bottom, that cereal bowl. Let's maybe pick a new color. Let's do blue. Okay, so all this part now. 2 pi r squared, 2 pi radius, still 39, squared. And I'm just going to type all that in and see what we get. Pi times 39 times, then you can do the asterisks, you don't have to. Square root of 3285. Make sure you hit the right arrow to get out of the radical, otherwise all the operations are going to continue inside. If you want to compute these one by one, you could hit enter if you're interested in knowing what the cone contributed only, or you could just add it all on if you want. So I'm just going to do plus, and then I'm just going to add on separately 2 pi, and then times 39 squared. Okay. So first part is the cone, second part's the hemisphere, add them up. Those lateral areas give us a total surface area of 16,579 points. What do we want to round to? Let's see. We are rounding to, oh, looks like it's freezing for a second here. Let's see. Ooh, what happened? 2 decimal places. Okay, so what does that leave us? 16579.07. 16579.07. And we are doing units feet squared for area. Okay, so there's total surface area. Total volume, I think, personally, I think is a little easier than total surface area because I don't have to worry about what surfaces can I touch versus what surfaces can I not touch. I'm just interested in the total volume of that hemisphere, how much space, how much cereal could I fit inside of that bowl, plus how much cereal could I fit in top of that or inside of that cone, and just add them all up. Hey, I see a hemisphere, I see a cone, I'm putting them together. So this is just going to be the volume of the cone plus the volume of the hemisphere. Volume of a cone is 1/3 pi r squared h if you look at your formula sheet. Some of us did 1/3 bh, maybe you prefer. Area of the base is a circle, pi r squared. There's our volume of a cone. And the volume of a hemisphere, you could do 4/3 pi r cubed. Find that and divide your answer by 2. Or since we have half a sphere, instead of using 4/3, I'm going to cut that in half and just use 2/3 pi r cubed. For me, that's faster to do. So now I plug in 1/3 pi, the radius was 39, square it. The height of the cone, not the height of the whole object, but the height of the cone was 42. And then plus, let's see what we get here. Ooh, it's having a little difficulty. I'll do it underneath. 2/3 pi times, let's see, radius was 39. This time make sure you're cubing it since we're doing volume. I'm going to highlight that. Pi r cubed. And now we're going to crank it out. So let's see what we get. And again, we're going to round this so we could just type this in all at once if we want. 1/3 pi times 39 squared. Don't forget to square that 39. Times the height of the cone, which was 42. Yeah. 42. This one's kind of long. I'm going to split this one up into 2 parts. Okay, so that's the volume of the cone. Now I'm going to do plus. You could do this all in one line. It's just getting kind of long. So that takes care of the first part here. Check. That's the 66,897 ... Plus, okay, now we're going to add on 2/3. So 2/3 in parentheses. Pi button. And then the radius was 39 cubed. So parenthesis 39, parenthesis, hit the exponent button, 3. All together, we get 1,91134.3 The 49 is followed by a 7. So if I round to 2 places, it would become a 50. 1911, approximately 1911. Oh, there's still more digits. Okay. 34.50. And this would be cubic feet. There we go. So there's our total volume of that bowl combined with that cone, how much space fits inside of that big object. Kind of looks like a pointy teardrop in a way, I guess. Or like a contact lens maybe with a cone on top. I don't know why you'd ever want to do that. Cool. Okay. So that gives you kind of our last set of shapes. We still have one more section to cover, but it's going to be a shortcut section that doesn't really use a lot of new formulas. So that should help with your homework. Happy mathing. Reach out if you have questions.